Whenever hydrogen combines with chlorine, hydrogen chloride is formed. Observe the chemical equation of symbolic representation of these reactions. From this representation, we can understand that one hydrogen molecule combines with one chlorine molecule to give two hydrogen chloride molecule. Instead of one hydrogen molecule, we take two hydrogen. After the reaction, there will be one hydrogen left. Now, you can check the table given below. Consider the chemical equation of preparation of ammonia. Here, the ratio between the number of molecules of nitrogen and hydrogen is 1:3. The same way, we can check the ratio between the reaction molecules from the given table. In every chemical reaction, there is a fixed ratio between the reactant molecules, and this ratio varies from reaction to reaction. Calculation of number of tiny particles. For instance, if there are 1 lakh 1 rupee coins in a bank, how is the bank going to calculate the number of 1 rupee coins? Similarly, do you know how to calculate the number of sugar grains in 1 kg sugar? For this type of calculation, the easiest method is to divide the weight of 1 kg of sugar by weight of 1 grain of sugar. In the same manner, we calculate the number of tiny particles. To calculate the mass of tiny particles, we use relative mass. Relative mass is dimensionless physical quantity, and it is the rate of the average mass of atoms of an element in a given sample to one unified atomic mass unit. The unified atomic mass unit, AMU, is defined as 1/12 of mass of carbon-12 atom. 1, that is 1/12 into mass of carbon-12 atom. 1U is equal to 1/12 into mass of carbon-12 atom. The following table shows the atomic masses of different atoms. In this table, the masses of hydrogen, helium, carbon, nitrogen, oxygen, phosphorus, chlorine are given. Let's find out what is gram atomic mass. The atomic mass of an element expressed in grams is called gram atomic mass, or GAM. Gram atomic mass and Avogadro number. The GAM of carbon-12 is 12 gram. Now, we are going to calculate the number of particles present in this carbon. For this calculation, we are using a new concept which is called Avogadro number. We all know that 1 dozen is equal to 12 numbers and 1 pair is equal to 2 numbers. In the same manner, we use Avogadro number. For each element, 1 GAM consists of 6.022 into 10 raised to 23 atoms. This number is called Avogadro number and is denoted as Na. We have have seen that 1 GAM of carbon-12 is equal to 12 gram. Now, let's calculate in 12 grams of carbon how many atoms are present. For the same, we use Avogadro's number. 12 grams of carbon atom is equal to 6.022 into 10 raised to 23 atoms. Similarly, we can calculate the number of particles in every atom if we know the atomic mass. Thus, we can find number of GAM corresponding to a certain mass of the element and the number of atoms present in it. Number of GAM is equal to mass in grams by GAM of the element. For more information, gram molecular mass, GMM. The molecular mass of an element or a compound expressed in gram is called gram molecular mass or GMM. The formula for calculating the number of GMM is number of GMM is equal to mass in grams by GMM of the substance. For example, GMM of water is 18 gram. Then, how can we calculate number of gram molecules present in 90 gram of water? We know that the number of gram molecules is equal to mass in grams by GMM. Here, the mass of water is 90 gram and GMM of water is 18 grams. So, by dividing 90 by 18, we get 5. So, number of gram molecule is 5. Similarly, number of molecules present in water is 5 into Avogadro number is equal to 5 into 6.022 into 10 raised to 23. If we take 1 GAM or GMM of any substance, the number of particles present in that substance is always equal to Avogadro number. This signifies the importance of Avogadro number in chemistry. Mole concept. The amount of any substance containing 6.022 into 10 raised to 23 particles is called 1 mole. For more information, the amount of any substance containing 6.022 into 10 raised to 23 particles is called 1 mole. One mole of oxygen atom is always 16 grams and it contains 6.022 into 10 raised to 23 atoms. Similarly, 1 mole oxygen molecule is 32 gram and it contains 6.022 into 10 raised to 23 molecules. So, if we take 1 mole oxygen atom and 1 mole oxygen molecule, their masses are different, but the number of particles present in them are the same. If we know the number of particles, we can calculate the number of moles using the following equation. Number of moles is equal to number of particles by 6.022 into 10 raised to 23 Na. Now, let's calculate the number of moles present in 1000 water molecules. For this, divide the given number of molecules by Avogadro number. In the same manner, to find out the number of moles of atoms, we use the formula. Number of moles of atom is equal to mass in gram by GAM. Similarly, to find out the number of moles in molecules of elements or compounds, number of moles of molecules is equal to mass in grams by GMM. Now, let us see how the mole number of the following is calculated. The number of moles of oxygen atom in 160 gram is number of moles of atom is equal to mass in gram by GAM, that is equal to 160 gram by 16 gram is equal to 10. Now, let us check the number of moles of oxygen molecules in 160 gram of oxygen. Number of moles of oxygen molecule is equal to mass in gram by GMM, that is equal to 160 gram by 32 gram is equal to 5. So, 5 mole is present. Do you know the number of moles of 160 oxygen molecule? Number of moles is equal to given number of molecules by Avogadro number, that is equal to 160 by 6.022 into 10 raised to 23. In the same way, we can convert the number of moles into number of particles or mass by using the following equation. For example, we can calculate the number of particles present in 4 moles of water. Now, let us calculate mass of 20 mole oxygen atom. Next, we can calculate molecular mass of 20 mole oxygen molecule. Volume of gases and number of moles. In case of gases, if the pressure and temperature remain constant, equal number of molecules will have equal volume. As the number of molecules in 1 mole of any gas is equal, their volumes also will be equal. This is called molar volume. For more information, have you heard about STP? It means standard temperature and pressure. That is, 273 Kelvin temperature and 1 atom pressure are known as standard temperature and pressure, or STP. At STP, 1 mole of any gas will have a volume of 22.4 liter. This is called molar volume at STP. That is, 1 mole any gas at STP contains 22.4 liter or 22.4 liter volume of any gas at STP is 1 mole. Number of particles in 1 mole of substance is equal to 6.022 into 10 raised to 23 and molar volume of 1 mole substance at STP is 22.4 liter. For more information, now we will check how to calculate the number of moles at STP. Mole concept and chemical equation. Do you know what is balanced chemical equation? Balanced chemical equation are those equations in which the number of each type of atom is made equal on the reactant side and the product side. Let's see the balanced chemical equation for the manufacture of ammonia. We know that 1 mole nitrogen molecule reacts with 3 H2 molecule to produce 2 molecules of ammonia. Such reactions allow minimum wastage of reactants, proper completion of reaction, and to reduce the pollution. Instead of 1 nitrogen molecule, if we take 6.022 into 10 raised to 23 molecule, similarly, we can convert the number of moles into mass as well as volume. From this, we can understand that when 28 gram of nitrogen combines with sufficient amount of hydrogen, it gives 34 grams of ammonia. Number of moles in solution. Now, let us calculate the number of moles in a solution. For calculating the number of moles, we use the term molarity. It is used to indicate the number of moles of solute in 1 liter of solution. Molarity of a solution is equal to number of moles of solute N by volume of solution in liter V. We can show this by using an equation. That is, M is equal to N by V. Procedure of preparing 1 mole solution. Take 2 beakers in equal volume. Take 1 liter water in first beaker and 58.5 gram sodium chloride in second beaker. Add 58.5 gram sodium chloride in the first beaker and then add water in the second beaker. Look what we can see